All right, nerds. Next part, we're going to talk about them identities. So we're just one frame down. Talking about the sine hyperbolic of negative x equals negative sine of hyperbolic x. Oh, that means that's an odd function. Yeah. Uh, Hyperbolic tangent is an odd function too, by the way. Sorry, throw it out there. Hey, cosine hyperbolic of negative x equal to cosine hyperbolic of just positive x. Hey, that's just like y equals x squared. That's an even function. That's an even function. So what we're going to do is we're going to show that sine hyperbolic is an odd function. And then once we're done with that, we'll go ahead and we'll prove this little identity. Cosine hyperbolic squared minus sine hyperbolic squared is equal to 1. Of course, the variable is x that I'm talking about. And then we'll use those sum and differences for our next one so we can go and prove our derivatives. Let's get it. So first, let's take our sine hyperbolic of negative x and show that that is an odd function. What we're basically saying is if we were to go through and replace all of our x values with the opposite sign, we would say that we would actually just get the same dang thing, right? So whack, whack, negative x, negative x, x, negative x, negative x, all over 2. And we're saying that this would be the same thing, that this negative would just be right out here at the outside. Well, let's go prove this thing. We're saying, is this true? So e to the negative x is going to become e to the negative x minus, well, that's e to the negative times a negative. That's just equal to a positive, all over 2. Well, what happens if we just turn this thing around? Make it negative e to the x plus e to the negative x, all over 2. Well, shit. Just factor out a negative 1 from the top. You don't have to do it from both. You do it from both, that's not going to work. So we get, that's going to change the first one sign to a positive. I'm going to change our middle sign. Oh, shoot. That's exactly what we wanted to show. We wanted to show that this was an odd function. So this is equal to sine, the negative of sine hyperbolic of x. Cha-ching, done. We've now shown that sine hyperbolic is an odd function. I would say that your turn. Go prove this. Go prove this on your own. Same game. It's going to work out no problem. All right. Now our next one. Let's go show this. Let's go show that cosine hyperbolic squared minus sine hyperbolic squared is equal to 1. That almost looks like cosine's double angle formula from trigonometry, but do not be mistaken. That's like the Pythagorean identity of hyperbolics, where it's cosine squared or cosine hyperbolic squared minus sine hyperbolic squared is equal to 1, and of course that's all the values of x. Well, let's go show it. So we have cosine hyperbolic squared of x. We claim that if you subtract out sine hyperbolic squared, that this is going to equal 1. Well, let's change everything into what it actually is. So it's e to the x plus e to the negative x over 2, and then we're going to square this. Minus, that's e to the x minus e to the negative x over 2, all squared. Okay. Well, let's square these things up. That means you need to write stuff twice. I'm going to slap the 1/4 on the outside because 2 squared. Let's not get too confused. So we get e to the x plus e to the negative x times e to the x plus e to the negative x. That's what squared means, right? Minus, we'll yank out that 1/4 and we get e to the x minus e to the negative x times e to the x minus e to the negative x. We could just take these 1/4, just yank them all the way to the outside. Let's see what happens. So we'll bring everything through so we get e to the 2x, right? E to the x times e to the x is not e to the x squared. All right, now we multiply e to the x times e to the negative x. Those are reciprocals of each other, hence that just equals 1. In the center, bang, that just equals 1 as well because a reciprocal. E to the negative x is 1 over e to the x. Multiplied by e to the x, we get that. And now we get plus e to the negative 2x. Oh, yes, there we go. Let's make sure to use a nice big bracket there. All right, now let's keep distributing through. E to the x times e to the x is equal to e to the 2x. Still is, not e to the x squared. E to the negative x times e to the x is equal to 1, but we have that negative sign, so we get negative 1. Once again, we're going to get the same thing in the center because it's a square. That better happen. And lastly, we're going to get, what's that, negative e to the negative x times negative e to the negative x. That's going to become positive e to the negative 2x. Well, cool. If we just remove these parentheses right here, let's just distribute in all of our negatives, clean stuff up along the way. I think we're about home free. So we get e to the 2x, and then the 1 plus 1 is 2, plus e to the negative 2x. Now we'll start distributing in our negatives. Negative e to the 2x. And that minus 2 is going to turn into a plus 2. And then that negative is going to come through and change that plus e to the negative 2x and negative e to the negative 2x. And let's start canceling stuff out. E to the 2x, negative e to the 2x. E to the negative 2x, negative e to the negative 2x, just leaving us with, what's that, 1/4. And 2 plus 2 is equal to 4. This equals to 1, and there we have it. We have just shown that cosine hyperbolic squared of x minus sine hyperbolic squared of x is equal to 1. I would go ahead and go and prove this 1 minus tangent hyperbolic squared of x is equal to secant hyperbolic squared of x. All right, in the next video, we're going to go through and we're going to look at sine hyperbolic of x plus y so we can prove our derivatives right down here. Now, for those of y'all that were wondering what your little homework assignment is, your homework assignment is, it's a quiz. The quiz is write one paragraph about an application of hyperbolics. What I mean by that is go get on Google, type in hyperbolics, go check something out, go find out something, and it can't be, don't give me anything about a catenary. Nope, not allowed to do this, not allowed. All right, no catenaries, no wavelength. No St. Louis Arch. Other than that, though, you choose what you want.